This lesson is about solving equations, and we're going to do that by using the square root property and also completing the square. So we need to learn the square root property first to be able to complete the square. And the square root property says that if a squared equals b, then a is equal to plus or minus, that's the positive and the negative of that square root. Because if you think about this, if I, like on this first example, it would be x equals plus or minus the square root of 49, right? That's positive and negative. And x is equal to positive 7 or negative 7. So you could write that this way. All right, two solutions. Now think about that. If I square negative 7, I get 49. If I square positive 7, I get 49. And that's the reason that we have to apply the plus minus notation, because we will have two solutions each time. On the second example, x is equal to plus or minus the square root of 20. And 20 simplifies, right? Because that's 4 times 5. So plus or minus 2 radical 5 will be my two solutions. And once again, you could go back and check this in the original equation, but no, when we square something, then we'll end up with a positive because we're substituting for that x. Okay. One of the rules for this is that you have to have your squared term isolated. So we're going to subtract 11 on both sides. And then you can see that when we take this square root, we're going to have an imaginary two imaginary solutions. So x is equal to plus or minus the square root of negative 11. Negative 11 is negative 1 times 11. So if we take the square root of the negative 1, that's I. So we have positive I radical 11 and negative I radical 11. All right, so we're going to isolate the x squared by adding 4 to both sides, and then, whoops, make sure I put that square on there, or exponent of 2, right? Divide both sides by 2, x squared equals 2, and then I apply the square root property that says x is equal to the positive and negative solutions of the square root of 2. All right, so negative square root of 2, positive square root of 2. And that's as much as we can simplify that, so we're finished with that one. And you can see this goes pretty fast when there's not too many steps involved. Now these look a little bit different, but they do work the same way. If I take the square root of y minus 3 squared, it's going to be y minus 3. So we apply that square root property the same way. We'll say y minus 3 equals plus or minus the square root of 4. Well, then I have to solve for y, right? So I'm going to add 3. This is really important. When you add 3 to both sides, the 3 needs to go in front of the plus minus. Also, we can take the square root of 4, which is 2. And then we have more simplifying, because y is equal to 3 plus 2 and 3 minus 2. So my two solutions will be 5 and 1. Maybe the other order would be better, 1 and 5, but either way it's okay. So just know that means 3 plus 2, 3 minus 2, we get two solutions. When you can remove your radical, then you want to go ahead and simplify this to just normal, in this case, whole numbers. Sometimes they'll be integers or fractions or something. All right, so let's apply the square root property to this next example. So 4y plus 2, right? Because I remove that exponent of 2 whenever I take the square root, and then plus or minus the square root of negative 25. So we can simplify the square root of negative 25, because that's negative 1 times 25. All right, so let's write this again. Now I'm going to have 5i, so plus or minus 5i. I need to subtract the 2, right, on both sides. So 4y, remember I'm going to write the negative 2 in front of 5i. and then we will divide by 4. Okay, now you can leave it in this form, right? Y equals -2 plus or minus 5i over 4. Or you could write it with two separate fractions. Right, so that would be -2 over 4 is -1/2 plus or minus 5/4 I. It's perfectly fine just to leave it the way it was here, and probably that would be the easier way to go. All right, so those are solved. Now notice that once again we need to isolate our squared term. So we're going to isolate by subtracting 8. So x plus 3 squared equals -8. Then we apply the square root property, making this x plus 3 equals plus or minus the square root of -8. Now -8 is going to simplify it because it's -1 times 4 times 2. So we'll be able to bring out a 2i. Subtract 3. Be sure that you write it in front of your positive negative symbol. And then 2i radical 2 for the radical part of this. All right, so on this next one we're going to have 3p squared equals -36 because we have to isolate the p squared term, right? The term first, and now we have to isolate p squared. So p squared equals -12. Notice I'm giving you lots of extra practice with simplifying negative radicals, or negative numbers under a radical, I guess I should say. So p equals plus or minus the square root of -12. And -12 is -1 times 4 times 3. So this becomes plus or minus 2i radical 3. All right, and that's it for that part. Okay. So next we're going to practice a concept leading to completing the square. This is where we take an expression and we're going to rewrite it as a perfect square trinomial, and there is a certain way to do that, and then we factor it. So the way we do that is we take the coefficient of our middle term, 2, we divide it by 2, and then we square it. Well, 2 divided by 2 is 1. 1 squared is 1. And so 1 will complete the square, right? It makes a perfect square trinomial. Now, these always factor as y plus 1 squared. So whatever half of your coefficient on your middle term was, or whatever that number was when you divide it by the 2, right? When you divide it by 2, you get 1. Or also you can look at it as the square root of that term, which is also in this case 1. All right, so this is how it factors. You may recall that from when you were factoring. This is a perfect square trinomial, which always factors as a binomial squared, right? So that's in factored form. This is the coefficient of my middle term, -8. So we divide it by 2 and we square that, right? So that happens to be -4. -4 squared is 16. So 16 is the number we need to complete our square to make a perfect square trinomial. And it factors as x minus 4 squared. So half of my -8 is -4, right? The square root of 16 is 4. In this case, it's always going to be a plus on this last part because, right, a negative times a negative is positive, positive times a positive is positive. So either way you look at that. And so we've found that number, right? The number that, the proper constant that completes our square, and then we write it in factored form. So on these two, they were both even. Even's always easier with completing the square. But when it's odd, we can still work with it. So if I take half of 5, right, 5 divided by 2. I'm not actually going to divide it. I'm just going to leave it in this form. So 5 divided by 2, and then I square it. So 25/4. And that is the constant term I need to add to make this a perfect square trinomial. You don't ever go to decimals on this because that would not work out when you actually are completing the square and solving. In factored form, this is going to be n plus 5/2. Remember, half of that middle term. And this always works out correctly. Now, I didn't show you that, but if you multiply these out, right, n plus 5/2 times n plus 5/2, then you'll have n squared plus 5n plus 25/4. All right, so this middle term is -1. So we take -1 divided by 2. And then when we square that, it's going to be 1/4. Right, so 1/4 is the number that we will use to complete the square. In factored form, this is y minus 1/2 squared, right? Because whatever that half of my middle term was, that's the number that's going to go in to make this in factored form. Okay, and you can always check this, right? Multiply it out, y minus 1/2 times y minus 1/2, and you'll see that you get y squared minus 1y plus 1/4. Okay, so the next part of this lesson is completing the square and solving, and so I'm going to show you that on the next video.